Okay, we're going to look at index laws, and it says extended because we're going a little bit further, a bit deeper into what we're actually talking about with index laws. The first idea we're talking about is that given something like this, where we have two numbers multiplied together, and they're all to the power of one number. Sometimes you'll see it written like this. What this means is that the first number, a, is to this power, the power of m, and so is the b. They're both to the power of m. So not only does this work for multiplying, it also works for dividing. So you say we're given two numbers and they're divided. Remember, a fraction is the same as division, a divided by b, and they're to the power of m as well. Well, we can break this up a little bit differently as well, exactly the same way. A to the m over b to the m. The only situation here is that bottom number, so say we have b, that can't equal 0, because if the bottom number equaled 0, then we wouldn't get a proper number. Okay, let's look at our first example. These we're going to expand. The first one, we have 5b to the power of 3. Now first of all, we're going to recognize that it's like this situation here. So I'm going to rewrite it like that. 5 to the power of 3 and b to the power of 3. Now, if we type into our calculator 5 to the power of 3, we're going to get 125, and b to the power of 3 will stay the same because b to the power of 3 can't be simplified any further. Let's try another example. Say we have something a bit more difficult, minus 2 x to the power of 3 y all to the power of 4. Now in this situation, we're going to do it again, but remember, going back to the last video, we have to multiply these powers as we go. So we've got minus 2, and that's to the power of 4. Notice I put brackets in there, that's quite important. And then we've got x to the power of 3 times 4, which is x to the 12, and then y to the power of 1 times 4 is y to the power of 4. Now we can simplify this. Now if you type into your calculator minus 2, but with the brackets to the power of 4, you're going to get 16. If you do it without the brackets, you're going to get minus 16, and that's not the same answer. So you need to make sure the brackets are in there. And then we're left with the x to the power of 12 and y to the power of 4. The last example we're going to do for this part is if we have something like this, 4 outside of c squared, d to the power of 3, all to the power of 5. Now in a situation like this, that 4, because it's not in these brackets, it stays there, it stays the same. But we have to do exactly what we did up here. So we've got c squared and 2 times 5, so that's going to be c to the power of 10, and then d to the power of 3, 3 times 5 is d to the power of 15. And that's our final answer there.